Again, another big thanks to Andrew. That was sort of slightly more last minute than I think we would have liked. So that was a massive effort for a somewhat spur of the moment presentation. And while we're on that note, if anyone would like to do a talk, a lightning talk, a longer presentation, maybe a bit of a shout out on some work they're doing, we do have a speakers nomination form. It should be on the meetup page. I'll double check that that's been reposted. So please feel free to submit a talk there. Bonus points if you submit a friend. If we all know really amazing people out here that are doing just incredible things, like I would nominate Josh, but he's already doing it. But yeah, we're all doing like there's so much amazing work that's going on in Melbourne, and sometimes someone just needs a bit of a nudge, especially if they're from an underrepresented community that we're not often seeing up on this stage. Big bonus points if there's a nomination going through for them. But without any further ado, probably one of the best set of memes in a slide deck I've seen in a long time. Joshy is a great co-worker of mine at Silver Fund, and this is some work that he's been doing with the autonomous vehicles with Andy, and we've tried to make a bit of space at the end of the meetup for lots of questions, but also for some playtime, really. We've got a racetrack set up and all that, so here's Josh.
Hey, my hair will go in lion mode by the end of this, so yeah, people have commented on the memes. I do like a good meme. So hi, I'm Josh, meme number one. I'm Josh. As Susie said, I work at Silver Fund. I've been there about 2 and a bit years. Recently graduated robotics mechatronics at Swinburne, and I got also a degree in civil engineering, but don't hold that against me. I was young and naive. So a while ago, I saw a talk here, actually, by Matt Kelsey. Some of you might know him. He alluded to this paper, which was like using simulation. I've got to read it. Using simulation and domain adaptation to improve efficiency of deep robotic grasping. Now, it's a bit of a mouthful, but essentially the idea is pretty much exactly what I'm doing here. So I train some behavior in a simulator, and then I try and trick the robot or the agent to think that it's actually in the real world, so that when I transfer it to the real world, it works, as opposed to just falls over. And I, around the same time, also saw this 2-minute papers video on CycleGAN, and it saw these really cool sort of visuals of it turning a horse into a zebra, which I thought was pretty cool. I'm like, I could make a simulator look like a timber floor. How hard can it be? Seems legit. But yeah, so there's a bit of jargon that I hear, and I'm you hear a lot, and some people, there's a bit of mixture of sort of skill levels here. So I'm going to try and introduce as many terms as I can as we go, and I've sort of culled some of the jargon. So if any of you are super experienced, and I might be using technically the wrong word, just bear with me. I'm trying to make it accommodate for everybody. But then, so after we just cover some terms, I'm going to go over why training and simulation is desirable. Why would I want to do this? And why I've chosen CycleGAN over some other methods maybe. And then we'll talk about a bit of the setup. So we'll talk about this little Donkeycar that we've seen going around here. I'll talk about the simulator. I'll quickly explain what a GAN is, if anyone doesn't know, followed by what a CycleGAN is, because it's kind of the next step up. And then I'll show you some cool results, and then we'll sort of take some questions if we've got time. So domain and domain transfer. So in our context, a domain is what the AI sees when it's doing stuff. So during training time, for example, and domain transfer is when you would take one domain that you've trained on and you try and make the network learn to work in a different area. So for example, in a different domain. So for example, say we're making a good dog, bad dog classifier. Yeah? These are my puppies, by the way. So I'm making a good dog, bad dog classifier. It's Bailey on the left, Ty on the right. We want to train this network on decent images of dogs, where the dog's kind of in the middle and reasonably in focus. We wouldn't want to train it on things like paintings of dogs or hand-drawn pictures of dogs or something. So in that case, the training domain would be real world images, and the test domain would want to be real world images. We're not doing anything fancy here. But in my case, the training domain would be a simulator, which is the one on the left, obviously, and then the testing domain or inference domain would be the track we have at Silver Pond's floor. So that's kind of like the idea between like transferring from one domain to another. But can anyone pick up on the glaring hole in the dog classifier?
All dogs are good.
Yeah, there is no such thing as a bad dog. But why? Why all dogs are good dogs? That's not the question. But why we want to transfer from simulated to the real world? Like, it seems a bit silly. It's not hard to just drive the car around that track like some of you saw Andy doing earlier. Like, gathering data isn't necessarily that difficult. You just sort of take your RC car and you just drive around a track and you get the data and you train your model and everybody's happy. But this isn't exactly scalable to like really like difficult situations or like nuanced environments. So like we're trying to do like some complex behavior to navigate this thing, for example. Manually gathering data to deal with this situation would be an absolute nightmare. So what other solutions do we have? And the previous talk kind of alluded to us. We do have this thing called RL, which is dope. So RL can like play Dota 5 and it can play Alpha. It can play Go reasonably well. So it stands to reason that we could probably learn some pretty badass driving behaviors. Unfortunately, RL algorithms are like super, super data hungry. I think anyone please pick me up on this if I'm wrong, but OpenAI 5 trained on like the equivalent of 200 years of human level play to get as good as it does. So, I mean, not really practical to do that in the real world. Another one is when you're training RL at the beginning, you crash a lot, you die a lot. And doing that in the real world, resetting a robot takes a lot of time and robots are expensive and no one wants to do that. So simulation provides a bit of a solution to this. We can, crashing robots are free, resets are free. We can expose the AI to the equivalent of hundreds of years of training time, and we can set up contrived examples that would be like rare or too dangerous to set up in real life. This is the main reason, anyway, for me, for wanting to be able to transfer from simulation to the real world for training like machine learning agents. So just quick recap. So we want to learn complex behaviors, but that's hard to do in the real world. So we want to use reinforcement learning, but reinforcement learning is really data hungry. So we want to try and train in simulation because that solves a lot of our problems. So we need a way to transfer the simulated to the real world. And how good is that picture for that? By the way, I was very happy when I found it. So just a quick bit of the setup. So we have, some of you might have seen it earlier, we have the Donkeycar down there. So it's just like a little scale electric car with some servos on it, a Raspberry Pi for the brain, and there's like this little donkey out, which was designed by some of the guys at CCHS, Connected Community Hackerspace, which is mainly just does some power supply and some motor control stuffs. There's the Pi camera, which is just uses for the eyes. There's my amazing picture of plywood, which is just for like the little mount there, and obviously like the chassis, and it's all programmed in TensorFlow Python. So cool. So normally we gather data by walking around the track, as you saw earlier. So for every frame of video you would capture, you would also capture the steering angle and the throttle command. Once you would just store that on the Pi whilst you're driving. Then you would take that data. When you're finished, you would put it onto like a bigger computer to train. You could train on the Pi if you wanted, if you hate yourself, but it might take a while. So I'd suggest you find a bigger computer to do that. Once you're trained, you then put your AI back onto the Pi and you cross your fingers and hope that everything works and you haven't just wasted an hour of your life driving a car around a track in a garage with no shoes on. So a shameless quick shout out would be that the guys at Connected Community Hackerspace, Andy has been instrumental in this, and Cameron Leeson from Make Create in Brunswick have facilitated a lot of this work, setting up tracks at their various hackerspaces, and also shipping in over 60 of these cars. It's charging, but over 60 of these cars from Shenzhen. And they're doing this meetup on Saturday where you can like learn to program these and drive them around and have one. You pay. Anyway. So the simulator. So this is like the Unity simulator that we used, or that I used. It wasn't my first choice. The first one is you can get it from the Donkeycar website. There's just like Donkey Sim. You click on it, it's a standalone executable, cross-platform. Kind of limited though, because you can't access the code. You can't get it. So I like jumped onto the Donkeycar Slack channel, talked to some people, and within an hour, it's really good. This guy, Torn, got back to me and pointed me at this actual simulator in the repo. So I pulled it down and now I can play God, which is good. Yeah, so quickly, so just the reason I wanted this mainly, like, so I could play with code, but also I can mess around with the, you'll see later, I can mess around with the floor, like sheen on the floor. Our tracks usually don't have dotted lines, but the first simulator I used did have dotted lines in the center. That kind of messed with things a little bit. So you can just really sort of tweak things quite nicely. So just a quick recap, or like a quick introduction to GANs. This isn't about GANs, so we'll just be quick. So GAN stands for Generative Adversarial Network. So the reason it's generative is because it creates something or generates something. So you would start with a seed, which could be a single number or anything. In our case, the seed would be an image from the simulated world. It gets passed through this generator, which would then try and generate a new image. In our case, we want to generate a picture of timber floors. And then it gets passed to this adversary. What the adversary does is also called a discriminator. What this adversary does is it tries to tell the difference. It tries to like classify this input image as like fake or real. And then these things train in tandem and they sort of feed off of each other. And as the adversary gets better at figuring out, telling the difference between simulated and real images, the generator has to get better at making simulated images look real. So these have reached this equilibrium. It's super awesome. But then we have CycleGAN. So why is it CycleGAN? So CycleGAN actually has two discriminators, or what was the word I used? Adversaries. Generally they're called discriminators, and I'm just trying to keep the words right. Anyway, so we have two adversaries and two generators. So here's our input image. It would first get passed to the first adversary to try and tell the difference. This adversary tries to figure out whether this image is from domain A or not. So in this case, domain of horse or not. And this image also gets passed through the first generator. So this generator tries to convert this image to look like a zebra. That zebra image gets passed through the second adversary to try and see if it's from domain B or not. And that image also gets passed through the second generator, which tries to convert it back into the horse domain. And what we do is we compare the original image and sort of the fake image and see and try and preserve what we call cycle consistency. So the reason I want to do this is because I want to make sure these lines that I have for steering remain constant when I go from the simulated world to the real world. So this is why I chose CycleGAN over other ones, because I wanted to try and preserve these lines, and I thought this might be the best way to do it. But to be honest, I haven't tried any of the other ways, so I don't know. This is a great repo. So this is the PyTorch repo for CycleGAN, written by the guys who wrote the paper. It wasn't my first choice. I originally went for this TensorFlow repo because I'm more familiar with TensorFlow, but it was garbage. So I bit the bullet and I tried this PyTorch. There's heaps of hard-coded stuff. I tried this PyTorch one and it works. It has a Docker container and I just run it and it just works. And that was nice. So good times. Would recommend. There might be a better TensorFlow one now. I don't know. So yeah, so this is simulator one, the image on the left here. So this is my first, that standalone one I was telling you about with the center lines. And then this is my target domain, which would be Silver Pond's office floor. So, oops. Attempt number one. See how we go. So unfortunately, this attempt number one, we didn't really learn about corners. It just kind of overfit to this sort of straight track with like a little tweak on the edge here, which is kind of disappointing. But I read through the paper, read some posts, and some peeps were saying that it's really sensitive to initialization. So if it doesn't work the first time, just try it a few more times, see if it just converges somewhere else. Another really annoying thing about GANs is you can't really rely on the loss function to just like plateau and then you go, sweet, I'm all good. that's not a really reliable way of training again. You've just kind of got to save checkpoints every n epochs and just try them all and see what looks good. So that's not fun, but anyway. So this is attempt number 2. So another thing they talked about in this paper was if you train for a couple of epochs, it sometimes will invert the colors and just diverge for, I don't know, who knows why. And this is an example of this like divergent color. It usually around epoch like sort of 3 to 5. If it starts doing this, just scrap it and start again if you're going to try this. I mean, it does pretty cool, but just not really working. So this one's a bit better. Let's try number 3. I added a little bit more data from here, but not like it already was like 11,000 images. So, I mean, and I went to like 15,000, so it's not huge. But we're getting better. What's interesting is you might see like this, it's really struggling with these dotted lines. So it tries to like make the yellow line a dotted line. But I mean, it's not horrible, but I figured I'll try again. Try number 4. I just like set it up in a loop and tried a bunch of them. Now this one's really cool. Before this one kicks off, the glare from the light on this right image, notice how it matches the dotted lines in the left image. It uses the glare to fit the dotted lines. It's super cool. Yeah, it's sweet, right? Not super helpful, but interesting. Okay, but this is a car trained on that very data with the glary dotted line things. So can we have a drum roll? Drum roll, drum roll, drum roll, drum roll. I'll skip ahead because it takes a little while to run. Here we go, here we go, here we go, here we go. Zooming out, you know what's going to happen. And it doesn't work. So I see a lot of talks and things online or like papers, and everyone just cherry picks all the good stuff. And it's like, yes, how easy is machine learning? You just like plug some stuff in and it works. I'm not going to be that guy. I'm going to show you all the stuff that went wrong. And then I'll show you something at the end that kind of worked, which is really nice. But this was trained on so there's 9,000 images from driving in this data set. And I trained on just that. Just as soon as it worked, I was like, that looks good. Train on it, see what happens. That happened, which wasn't ideal. But what we usually do when we train the Donkeycar is we try and mirror the data set. So we like flip the images horizontally and we multiply the steering commands by -1 to flip them as well. So then we have an even number of left turns and right turns, or your left turns and right turns. So I thought like this thing just banged a right straight away with like no regard for what was going on. So I thought maybe it's just overfit to turn right. So like I mirrored the images and tried again. Halfway. And this one was like a little bit more promising. So it kind of follows it. Yeah. I was like, oh, this is pretty good. This is pretty good. And I was like, okay, what else can we do? And I was like, okay, I'll add lots of data augmentation. So that's when like I will cut out bits of the images and just make them black. I'll add salt and pepper, so just like white noise across the image. I'll add what I call hundreds and thousands, where I just randomly add RGB pixels all over the place. And I also do like an image overlay. So I downloaded like a small, CFAR10, like 1,000 images from CFAR10 data set. And I do like a blended image of just like a toilet on top of it, just to add some random crazy noise to this thing. And I flip the color channels. I just do all kinds of crazy stuff just to make it learn about the damn lines. That's all I really care about. So then I tried that. And then this thing happened. And that is not the slide I wanted. And then this thing happened. Okay. 9,000 images plus mirror plus augmentation. Holy crap, it does a thing. This made me very happy. But I was still annoyed by the glare from the lights. I thought we can make it runs into the table leg, I guess, to the end there, which isn't ideal. But that's the table's fault, jumped out in front of the car. Yeah, see, right? So I use this different simulator. So this is when I contacted the guys on the Donkeycar Slack channel, and I downloaded this other simulator, and they didn't have any tracks without dotted lines, but I just got my wife to draw up a PNG with straight lines. It's great. And then trained it on this track, and it looks quite nice. I mean, we don't have this like problem with the glare. kind of learns about the lines quite well. It doesn't have like the dotted line glare problem. We have another glare problem. So we get up to, oops, good times. Let's just like skip ahead a little bit. Yeah, okay. So notice like the line at the back here kind of just dips off to one side. This happens whenever there's this white glare in the background. So I thought the road's too shiny. This is annoying. Maybe but I did, back a bit. I did deploy this onto a car though. I was like, oh, let's see what happens. So I deployed this onto a car and I got this. So this is can't really read it, but the blue line is the prediction. And the red line is the ground truth steering commands by someone driving the car around. And I was like, oh, this is garbage. But it kind of tracks it, just the scale's wrong. Don't know why. Scale's wrong. So I just multiply it by 4, and it looks pretty good. So I want to drop this into a car and see if it actually works. My guess is it's something like either the frame rate in the simulator is too small, or because I train in the simulator, I use like a PID loop to train. So PID is just it tries to follow the center line in the simulator. And you have this information because you are God in the simulator. You can know everything about everything. So I can follow the center of the track. But if I follow the center of the track, it drives really conservatively and barely touches the steering wheel unless it needs to. So we don't have anything in here, but later iterations, I've just made the robot randomly teleport off the track every like 200 frames. So it goes, oh, and it goes back on. So it's got to like really drastically steer to stay on the track. But I was like, I wanted to try and get rid of this glare problem. So I was like, I'll remove the sheen from the concrete and try again. And then this looks pretty good. Spoiler alert. Once it loads. So here we go. And the lines are really stable. I'd use a different random seed in this environment, so my tracks cross each other, which is fun. But it works. I mean, there you go. That was pretty good. So I was like, I'll double down on this no sheen thing. And I'll just go, all right, let's just go matte black with white lines, see what happens. Not horrible, but not as good as the other one, I don't think. So yeah, this is exactly the same track, just with matte black finish on the road. I don't know where they come from. There's some other thing. Yeah, what's cool is you can see the shadow. If we go back to the beginning of this video, you can actually see the shadow of the car down there, which is pretty awesome as well. But yeah, that's a talk. Don't forget about the autonomous vehicle thing on Saturday. I won't be there, but it should be good. Does anyone have any questions? Or...
Are you going to demo stuff?
Oh, the thing we were doing earlier isn't this.
Oh, okay.
I wanted it to be, but I didn't have like decent data of Zendesk's floor to do it. So, but now we do. So next time. Yeah. Yeah, I haven't got any images on here, but because of the nature of this CycleGAN thing, it actually does produce both. So I do have the generator that can go from real to sim. But from this experiment and a bunch of others I've done, I found that it really struggles going from real to sim. It does much better from sim to real. But I've only ever had real in like domain B. I've always had, no matter how I've ever set this up, you can set it up to have like domain A and domain B, which would be sim and real. I've only ever had it that way. So I don't know if it's like some artifact of the code, and if I switch it around, maybe it'll work. But I don't know. I did think of that though, but time. Any other questions, comments, queries, concerns?
How long do you train
Surprisingly not long. Most of those, I think the longest, the amount, so there's about 11,000 images from sim and real in the training set for both. And it took about 7 hours to train the GAN. So I just set it up on a loop to train over a bunch of different data sets and then generated a bunch of videos and saw which one looks better. But yeah, about 7 to 8 hours. Once it gets about past epoch 5 to 8, it just starts to go to garbage. You just see it go better, and it just goes and just goes crazy checkerboard patterns everywhere. You just lose everything. Yeah.
How big a leap do you think would be to,
Yeah. So I guess the goal would be to sort of simulate like a real traffic environment and then just have the car crash into a bunch.
hard as it is?
Yeah. Haven't even looked at it. I presume it sounds hard, but I mean, yeah. I mean, on the surface, like you could naively say it sounds easy, but as soon as it sounds easy, it's not. So, yeah, I haven't really thought too hard about it. I was just assumed that someone would have already done that, and I'll just chuck my thing in and hope it works. Yeah. 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 Well, the next step is Andy mentioned it this afternoon actually, is we want to try and simulate these cups on it. So we put the cups on the ground, and maybe I'll put like a marker in the simulator and see if we can simulate red cups as well, and then I guess scale from there and cross fingers. Try the same thing over and over again with different random seeds and see what happens. Anyone else? Yes?
Shown quite a lot of attempts and variations, and those were assessed by you looking at them. Do you have any other way to determine?
No, it's kind of hard to like numerically define what woodiness of silver bronze floor looks like. It's kind of the well, it's kind of I guess that's kind of the discriminator's job, but even that doesn't work as well as you'd hope. You'd hope it'd just get really good and everything would converge and you'd go home with this perfect generator, but life sucks. It doesn't. But no, I don't have anything other than just going, that one looks good. Yeah. Is there a better approach? I'd like to hear it. Some people, I've heard people talk about like grid search or something, but kind of just like directed trial and error. So sorry, I don't have a nice answer for you. It's kind of the generic thing for a lot of ML stuff is, do you have a better answer? No, just try it again. Stir that linear algebra pile and see what happens. Cool. Sweet. Oh. Oh, absolutely. The only thing I would probably change is OpenAI did people might have seen that hand manipulation with the little box with the letters on it, and it tries to manipulate it to find the green face with the A on top of it, or to face up. They used RL for that, but instead of trying to make the simulated data look real, they just made the simulated data crazy. So because you're in simulator, you can like change the textures, change the lighting, like flip things, move things around, just go absolutely bananas. So I think like the idea behind that was to remove any artifacts from the environment that aren't important. If I just randomize everything that isn't important, hopefully the network will only learn the important things, is I guess the intuition behind it. And they also use CycleGAN, and they had the randomization method took longer to converge, but worked better to transfer it. So I'd probably try that as well. Top couple of things to try next. Cups. Figure out why the hell that multiply by 4 thing is a thing. And different floors. Every time I've like tried to go from simulation to real world, it's always been to a timber floor. And someone pointed out to me that timber floors are probably like the worst thing to go to because they already consist of lots and lots of lines. So maybe a simpler floor might be a simpler target domain might be in order. Nor am I. Well, like there's like 11,000 frames in there, and it tracks the entire video. So, I don't, but it might not be 4 all the time. It could be some other number. Who knows? Or it might just be that one video that I did. I honestly don't know. You are more likely than not that you're correct. Oh, the human-driven data is so noisy. Andy is a terrible driver.
See, oh, well, let's give Joshi a bit.
Just